morning, good afternoon, good evening, wherever you may be. Welcome to this GCEA Technology Snapshot. The importance of oxygen in the COVID pandemic response is well known. Even before COVID, oxygen had been recognized for its importance in healthcare delivery and indeed classified as a medical device. Although medical-grade oxygen is scarce and costly, there are options for its generation, including the millions of PSA plants that have been acquired during and following COVID. Water is also a scarce resource, essential to not only healthcare delivery, but community wellness as a whole, and indeed life itself. One could therefore argue that water, although not classified as a medical device, is the most impactful and cost-effective health technology. Unlike oxygen, however, water cannot be created or generated and must be managed as such. We are indeed privileged today to be addressed on a specific topic of water management for the hospital environment by our Brazilian colleague, Jorge Pereira. Jorge graduated in automation and control engineering and has MBAs in clinical engineering, project management, and health executive management. He is also an accreditation evaluator with a professional career spanning over 35 years in maintenance and management of biomedical equipment in a technology-rich hospital environment. Last but not least, Jorge is also a regional director of the Brazilian Clinical Engineering Association, ABICLIN. Jorge, the floor is yours.
Hello, dear colleagues from Global Clinical Engineering Alliance, and hello for all world community of clinical engineers. I am Jorge Pereira, a Brazilian clinical engineer, and it's a great pleasure to be here to present this GCEA technology snapshot. We will talk about water as a critical supply input in hospitals. Its use ranges from nutrition, hemodialysis treatment, medical device processing, to the hygiene of the bone marrow transplant patient. Water is a critical for infection control, and in hospitals, water is a vital life support. Is your hospital water treatment system prepared to offer quality and safe to your patient? That is our main question that we try to answer. In order to answer this question, we will talk about some points. First, where water management is important in a hospital. How to classify the level of risk importance. Management of hospital water system is critical and costs a lot of money. It's important to invest correctly and efficiently your budget. What legislations and standards affect this issue? Of course, standards and laws about water are different from country to country. Third, water pre-treatment. It depends on the characteristics of the drinking water from public treatment system. It is the first and very important barrier. If this barrier works in accordance within limits required for the next hospital water systems, for example, reverse osmosis or security filters, you will have this high performance of these water treatments and lower cost of maintenance. 4, physical, chemical, and microbiological parameters control. If you can't control what you don't measure, you must know your enemy if you want to beat them. That's very important. You can't control what you don't measure. Okay. 5, nutrition and personal hygiene is an undervalued risk that can affect a large number of patients and hospital personnel. 6, hemodialysis, life support with high risk of infection through the water. And 7, processing of medical devices, a process that can interfere with the operation of all hospital services. Medical devices processing department supplies from a simple swab to most complex surgical package. And 8, bone marrow transplant. This is when the patient has immunity 0, and if a bath can be lethal. What are the goals to be achieved with other treatment management? If you achieve these following goals, the operation, hospital, and patient will be safe. First, physical and chemical and microbiological parameters control. What needs to be controlled? In which point of the hospital water distribution system the samples must be collected in order to offer a real picture of safe or contamination. Second, mapping of treatment and distribution process. What are the vulnerable points of your water systems? Second, number 3, consumption monitoring plan. Do control the consumption and losses. Water is a critical and expensive input product for a hospital. Rational consumption and rigid control of losses is essential for business sustainability. 4, map and risk management plan. What are the risks? Do you measure, manage, and mitigate this risk? If not, your hospital and your patient and your healthcare business are in danger. 5, quality management standards. Does your hospital water treatment comply with the quality set out in the standard and legislation of your country? Take care. 6, critical analysis of quality control reports. Do you know to interpret the results of quality laboratory reports? This interpretation is crucial. Which country has its own laws and standards? However, the AAMI, Association for Advancement of Medical Instrumentation, has published recently, in the summer of 2023, the standard number ST108. This standard provides guidelines for selecting the water quality necessary for the processing of categories of medical devices and addresses water treatment equipment, water distribution and storage, quality control procedures for monitoring water quality, strategies for bacterial control, and environmental and personal considerations. Even though it's not applicable as a standard or law in our country, it is a gold standard reference for water control quality. But the most important, of course, the most important step is to know your country laws and the standards about water. The first defense of your hospital water system is the pre-treatment. The system must block or control unwanted physical, chemical, and microbiological elements present in drinking water. Example of these elements are chlorine must be controlled, iron, calcium, suspension materials, and pathogenic organisms. All this must be eliminated. Drinking water from public treatment system, even with all its parameters within legal limits, can be a dangerous threat to our patient as well, to the hydraulic infrastructure and the secondary water system, such as reverse osmosis. Normally, the pretreatment system consists of multimedia filter, control suspension materials, activated carbon filter for chlorine control, softener filter to control water hardness, and security filter to control microorganisms. And after all this system, you must have one chlorine dosing to reconstruct the chlorine doses. Now, with your first barrier installed, we must study, understand how to monitor and control our secondary water treatment system. After your pre-treatment, your mapping of treatment and distribution process, as well your mapping and risk management plan, will address to define where, who, and how to mitigate or eliminate water system risks. In a hospital, water is used in several processes. For example, nutrition, personal hygiene, hemodialysis, medical device processing, and even so for personal hygiene of patient of bone marrow transplant. Each one requires a specific post-treatment. For example, hemodialysis require double pass reverse osmosis. Hemodialysis is a life support and a long-term treatment and invasive. Water contamination can be fatal for the patient due to the risk of infection through dialysate fluid that has water as one component. That is why water treatment for hemodialysis requires double pass reverse osmosis. However, the medical device processing requires single or double pass reverse osmosis, depending on the quality of input water. A medical device processing water is not important only for high quality steam production for sterilization and reduction of risk for infection through medical device, but also for prevents damage like corrosion for the medical devices. Water is very important for bone marrow transplant cares. Bone marrow transplant patients are very vulnerable to infection due to the very low or zero immunity caused by the treatment itself. Patients must bath using sterile water during their stay in their BMT room in order to minimize infection during this critical time. In addition to all the risks involved in hospital water treatment, we must also consider some external risks, such as floods, earthquakes, tornadoes that can produce a mixture of contaminated water with water from the hospital system. Another external risk is the increase of global temperature, which can cause an increase of water temperature and thus facilitate the growth of pathogenic agents. This must be included in your risk management planning. In summary, reliable availability of pure water is fundamental to the operation of hospitals, ensuring the delivery of high-quality healthcare services, maintaining hygienic environments, and safeguarding patient well-being. Water plays a critical role in ensuring the safety, efficacy, and success of medical procedures, such as hemodialysis, medical device processing, and bone marrow transplanting within hospital settings, as well nutrition process and personal hygiene of patients and hospital personnel. I hope sincerely this summary information about the hospital water treatment system can help you to organize and manage your hospital water system in order to offer safe and quality medical assistance to your hospital patients. Thank you very much. I hope to see you at the next GCEA Technology Snapshot events. Bye-bye.